Hi there, and welcome to this lesson. In this lesson, we'll be learning trigonometric ratios, okay? And under trigonometric ratios, we'll be learning SOHCAHTOA. SOHCAHTOA, okay? Now, what is this SOHCAHTOA? It's a very, very, very strange looking topic, but we'll find out all about it shortly, okay? SOHCAHTOA. Now, as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, trigonometric ratios, SOHCAHTOA. Now, what exactly are trigonometric ratios? Now, trigonometric ratios are ratios of the sides of a right angled triangle. So we've learned about a right angled triangle. We've learned about some very unique properties of the sides of right angled triangle. We learned the hypotenuse, the opposite, the adjacent, and how Pythagoras' theorem relates all three of them. Okay, but then we have an even more interesting relationship between the sides of a right angled triangle, and what we have is we have trigonometric ratios, and they are very fixed, constant ratios that relate the sides of a right angled triangle, and are often related to the angle of the triangle. We'll find out about all of that shortly. So, trigonometric ratios. Now, we have three trigonometric ratios, okay? We have sine, cosine, and tangent. So the first trigonometric ratio is sine, the second is cosine, and the third is tangent. And like I mentioned already, these ratios are the ratios of the sides of a right angle triangle. Now, sine is the ratio of the opposite and the hypotenuse. Okay, so ratio of the opposite and hypotenuse. Cosine is the ratio of the adjacent and the hypotenuse, and tangent is the ratio of the opposite and adjacent. Okay, now let's understand all of this. So we have this triangle here, okay, and this triangle has an angle inside called theta. Okay, now the side opposite this angle is our opposite. Okay, so our right angle triangle, we have the side opposite our angle is our opposite. Okay, and then our longest side is always our hypotenuse. So what it is that there is a relationship for a given right angle triangle. There is a relationship between the length of the opposite and the length of the hypotenuse, and that relationship, opposite over hypotenuse, is the sine of the angle in the triangle. Okay, so if you have a triangle, you have an angle in there, okay, and you have the length of the opposite, the length of the hypotenuse. The relationship between the opposite and hypotenuse, the opposite divided by the hypotenuse, is the sine of that angle. Okay, very, very important relationship, and you will understand exactly why these are very important as we go on. So sine of theta equals opposite over hypotenuse, and this is exactly where our SOHCAHTOA comes from. Okay, and this is actually so, S for sine, O for opposite, and H for hypotenuse. Okay, so SOHCAHTOA is just something we use to remember our three trigonometric ratios and exactly what they stand for. So the first bit, SO, stands for sine equals opposite over hypotenuse, SOH. S for sine, O for opposite, and H for hypotenuse. So is sine of theta equals opposite over hypotenuse. Now similarly, we have cosine. Okay, so I said we have three of them: sine, cosine, and tangent. Now for cosine, you're working with the adjacent and the hypotenuse. Okay, just look at what we have there. We have ka, so cosine equals adjacent over hypotenuse. So cos of theta equals adjacent over hypotenuse, and this is where we have ka, C-A-H, ka. Now finally, we have TOA, okay, and what do you think TOA stands for? So TOA is opposite over adjacent. So tan of theta is opposite over adjacent, and that's what we have TOA. So that's what we have. We have SOHCAHTOA, and that's pretty much what we're going to be learning in this lesson. Okay, the trigonometric ratios, SOHCAH, and exactly what they stand for. So the first one, sine, stands for opposite over hypotenuse. So the second one, that's SOH. The second one, ka, cosine. We have adjacent over hypotenuse, CAH. And then tangent, tan, equals opposite over adjacent, TOA. Okay, now the trigonometric ratios of an angle are always fixed. Okay, so sine of a given angle is always a particular number. For example, you have that the sine of 30 is the sine of 30 degrees is 0.5. Okay, and what that means is for every triangle that you have, if you have 30 degrees in that triangle, okay, the opposite divided by the hypotenuse of that triangle would always be 0.5. So however long you draw that triangle, okay, the relationship between the as long as the angle in the triangle is 30 degrees, the relationship between the opposite and the hypotenuse would always be opposite divided by hypotenuse is 0.5, or the hypotenuse would always be twice the size of the opposite. Or basically, if you have a different angle, another angle, I think let's say 60 degrees, sine of 60 degrees is about 0.8660, something like that. And what you have is you have the relationship between the opposite and the hypotenuse. So as long as your triangle has an angle 60 degrees inside in the angle, it doesn't matter how big the triangle is. The triangle could cover the Earth's surface. It could be as big as you, but basically the opposite would always, the relationship between the opposite and the hypotenuse would always be the sine of the angle inside. So, and then we can get these values. Basically, we'll just have sine 30 is 0.5, sine 60 is 0.8660. We can get the sine of pretty much any angle. You can even have angles with decimals, so you can have something like 24.625, and you can find the sine of 24.62. 5, basically you can do that with a calculator, but you won't be able to do that with tables. So what's this is, you can find the sine or the cosine or the tangent of pretty much any angle, and you do so using a calculator or trigonometric tables. Now trigonometric tables are limited to 4 digits, so if you're looking to find the sine of 24.625, you would not be able to do that with trigonometric tables, but you can most definitely do that with your calculator. So now, using a calculator, so get hold of a calculator, and I will need you to find the sine of 72, the cosine of 29, and the tangent of 53. So the sine of 72, basically we have sine of 72, and what we have is we have 0.9511. So if you go on your calculator, you find sine, you just have sine of 72, and it's to give you 0.9511. The cosine of 29 is 0.8746. So if you go on your calculator, you find the cosine of 29, you should have 0.8746. Finally, the tangent of 53 should give you 1.3270. Now, usually all of your trigonometric ratios, they're often less than 1. With the one unique case, we have tangent of some numbers. Tangent of numbers of angles greater than 45 are always greater than 1. Okay, but for pretty much any sine or cosine, you'd always have the value less than 1. And if you think about the relationship between the sides of your triangle, and you remember that the hypotenuse is always the longest side, you could probably understand why sine and cosine are always less than 1. Okay, so now given the trigonometric ratios, we can solve for missing sides in a right angle triangle. So what it is if you have, for example, if you have a triangle with 30 degrees in it, okay, and you're given the opposite of that triangle and you're asked to find the hypotenuse, how would you go about doing that? That's what we're going to be talking about now. So we already know that for a 30-degree triangle, the relationship between the opposite and the hypotenuse is 0.5, i.e. the opposite divided by the hypotenuse is 0.5, or the opposite is always twice the value of the hypotenuse, and the hypotenuse is always twice the value of the opposite. So if you had a right angle triangle, and then basically you had a right angle triangle and you're told it had 30 degrees inside, and you were given the opposite at say 5, the hypotenuse would be 10. Okay, now Here's something interesting. So basically we have this, and in this triangle we have 72 degrees, okay, and we're given the hypotenuse and we're looking to find the opposite. Okay, with the opposite is missing, the opposite is x, and the relationship between the hypotenuse and the opposite, we make use of sine. So we're working with so, and sine of the angle is opposite divided by hypotenuse. So we have that sine 72 is our opposite x divided by 7. You find from what we did before, we have that sine 72 is 0.9511. Okay, so 0.9511 equals x over 7. And then from this point on, it's just a simple matter of algebra, and you just go cross multiply. You have x equals 7 times 0.9511, and what you have in the end is you have x equals 6.6. Simple, straightforward. Another example, okay, so we have this triangle, and what we have in this case is we have a triangle with 29 degrees inside, okay, and then we have our adjacent as 11 and our hypotenuse as x. We're looking to find our hypotenuse. So we have this triangle, and from what I explained already, basically for a given triangle with a particular angle, the relationship between the sides of the trigonometric ratios are always fixed. So the trigonometric ratio in this case, the cosine of 29 is 0.8746, and what this means is that for any triangle, however big the triangle is, as long as the angle inside is 29, the relationship between the adjacent and the hypotenuse would always be 0.8746. So if you're given a triangle where the adjacent is 11 and you're looking to find the hypotenuse, you can just go ahead, work the algebra. You have that the cosine of 29 equals 11 divided by x, 0.8746 equals 11 divided by x, and you work your answer, you should end up with x as 12.58. Another example, we have the tangent in this case. So we just go tangent, we have adjacent as 4.7, our opposite as x, okay, and the trigonometric ratio that relates opposite and adjacent is the tangent. So we have the tangent of 53 equals x divided by 4.7, and then we just work the algebra. We find tan 53, it's 1.3270. We work the algebra and we should end up with x equals 6.24. Simple, straightforward. Now let's just run through a few examples, okay, very quickly. Example 1, and we have solve for the missing side in the right angle triangle below. Okay, so we have all we have here is we have the opposite and we're looking for the hypotenuse, and we're given that the angle in the triangle is 30 degrees. Now if you have opposites and hypotenuse, the trigonometric ratio you'll be working with would be sine. Okay, so we have the first one, we have the formula that sine of theta equals the opposite over hypotenuse. So that's SOH, sine equals opposite over hypotenuse. Now you have our theta as 30 degrees, our opposite as 12.3, and we're looking for our hypotenuse, okay? And basically the sine of 30 equals 12.3 divided by h, okay, and you find the sine of 30, it gives you 0.5. If you punch sine 30 into your calculator, you would end up with 0.5 equals 12.3 divided by h. You have h equals 12.3 divided by 0.5, and what you have in the end is you have 24.6. It basically follows the rule for a 30-degree triangle, for a 30-degree right angle triangle, the hypotenuse is always twice as long as the hypotenuse is always twice as long as the opposite, because that's the relationship basically. It's one of the cleanest trigonometric ratio, sine 30, where you have just 0.5. Usually pretty much every other angle would give you a very long decimal number. We usually approximate to about 4 digits, but for 30 degrees has a unique relationship in that it's actually 0.5, or better read, the hypotenuse is always twice the length of the opposite. Another example, example 2, Okay, so we have 24 in this case, and we have opposite, and we're looking for adjacent. Okay, so opposite and adjacent. The trigonometric ratio would use for opposite and adjacent. What is that? It's tangent. Okay, and we have that tan theta equals O over A. And then basically we have that theta equals 24 degrees. O in this case is 6, and we're looking for A. We have that tan of 24 equals O over A equals 6 over A, and tan 24, if you punch that into your calculator, you'd have 0.4452. Okay, and that equals 6 over A. And then basically when you work that out, you should end up with your final answer for A. Simple, straightforward. I think we'll have a few more examples, okay? Very easy examples. Example 3. And we're looking for the missing side in the right angle triangle below. And what we have inside the triangle is 44 degrees. And we have our adjacent and our hypotenuse. And basically we're going to apply cosine. We have theta equals 44, hypotenuse is 19.5. And we're looking for the adjacent. So we have cos 44 equals the adjacent, that's adjacent over hypotenuse. So we have that, very simple, and we have our final answer. Final example. Okay, so we have this one. If sine of theta equals 3 over 5, find cos theta minus tan theta. Okay, now if the sine of theta equals 3 over 5, what we're going to do is we're going to draw a triangle. Okay, and the sine of theta equals, so we have theta in a triangle, and the sine of theta equals 3 over 5. And what this means, if you remember, the sine of theta is the opposite over the hypotenuse. So what this means is that the opposite of this triangle is 3 and the hypotenuse is 5. Now we're looking to find cos theta. To find cos theta, we're going to need the adjacent. And to find the adjacent given the hypotenuse and the opposite, we simply make use of Pythagoras' theorem. And basically, looking at this triangle, you should already be able to tell that the adjacent would be 4. Okay, basically 25 minus 9 will give you 16, and root of 16 will give you 4. And this would tell you that the cosine of this triangle would be, the cosine of the angle in the triangle would be 4 divided by 5. And the tangent will be 3 over 4. And to find cos theta minus tan theta, we just do 4 over 5 minus 3 over 4, and we end up with 1 over 20. And that would bring us to the end of this very simple, very straightforward lesson. Okay, you can go ahead now and attempt questions on the worksheet. Bye for now.